Lesson 10-2, measurement in circles. Circumference is the distance around the outside of a circle. This is also known as the perimeter of the circle. Below you have two formulas. We can either use C equals 2 pi r or C equals pi d. It really just depends on whether you're given the radius or the diameter. Below we have two examples, and let's look at using those. So in the first one, you are given a radius of 8 inches. So what we should use is the formula that involves r. So we're going to use C equals 2 pi r. So it's going to be 2 times pi times our radius, which is 8. So for our exact answer, C is going to be 16 pi. Our unit is inches, so this will be in inches. This is exact. To get an approximate to the nearest hundredth, this is when you pull out your calculator. You'll type in 16 pi, and you'll find out that C is approximately equal to 50.27 inches. And again, this is your approximation. Students frequently feel like the decimal is more exact, so it should be your exact answer, but that's not true. Pi is an exact number. The 0.27 is rounded off. So let's look at the next one. This time what you're given is a diameter of 11 meters. So we should use C equals pi times diameter. Stop the video and try this one on your own to make sure that you understand it. Hopefully what you've got is pi times 11, so our exact answer would be 11 pi meters. Your approximate answer, when you type this into your calculator, you're going to get this to be approximately 34.56 meters. It's important to note that pi is not 3.14. Most of the time if I ask a student what pi is, that's the answer I'm going to get. But that's not true. It's an irrational number, and it describes the ratio of a circle's circumference to its diameter. So, for example, if we take the formula C equals pi d and solve for pi, we would divide both sides by d, and we would find out that circumference over diameter is what pi is. So let's move on and talk about arc length. Arc length describes a piece of the circumference of a circle. All right, to find arc length, which is just like the crust, you can either use a proportion, thinking each side as part over whole. The arc length is a part of the total circumference, and the central angle measure is part of the whole angle measure of 360. Remember, your central angle is the angle with the vertex at the center. If you solve this for arc length, you can use kind of a shortened version of this just by putting the central angle measure over 360 and multiplying by the circumference. So let's look at some examples here. We're going to find the arc length of arc AB. And AB is not labeled, so we're going to say that's A and that one's B. So my central angle is 60 degrees. So if I'm going to use the proportion, I would have 60 over 360 equals what I'm looking for over the total circumference. So I need circumference. The problem's giving me radius, so I'm going to do 2 times pi times the radius. So my circumference is 14 pi. Always use the exact form when you're working through these problems. So I'm going to put 14 pi right here. Now I can cross multiply, and I'm going to get 360x equals 14 pi times 60. When I divide by 60, I'm going to find out that x would be 7 over 3 pi, and this would be measured in inches. If I choose instead to use the shortened version, I would just be looking at 60 360ths of 14 pi. And if you notice, when we worked this problem a minute ago, that's really what we end up doing right here, because we're dividing by 360. So now let's take a look at the next one. start by finding your circumference. So since they're giving me a diameter this time, I'm going to use pi times my diameter, so my circumference would be 6 pi. So if I want the length of arc DE, I have a central angle of 48 degrees. So the arc length of DE would be 48 360ths of 6 pi. When I simplify this, this is going to give me 4/5 pi, and this would just be units. Okay, we are also asked to find other arc lengths like ECD, CDE, and DEC. So let's stop and consider the question about the relationship between DE and ECD. Well, let's think. Here's DE, the one that we just did. ECD means I'm going to start at E, go through C, and not stop until I get to D. So if you look at this, this is all of the circumference except for the piece from D to E. So it would be the whole, well, what we want to look at here is that arc DE plus arc ECD would be the whole circumference. So we can kind of use this to help us. So to find arc ECD, what we can do is take the whole circumference, which we know is 6 pi, and subtract away the piece that we already know is DE, which would be 4/5 pi. Once we go through and do the subtraction, this is going to give us 26/5 pi for arc ECD. So let's look at the others. I have arc CDE and arc DEC. Well, let's look at CDE. C starts here and goes through D and stops here. Think of this as part of the circle. This is half the circle, which means it's half the circumference. So it's half of 6 pi, so it would be 3 pi. See if you can do the last one on your own. Stop the video and resume it when you have an answer. Hopefully what you're seeing is that arc DEC is made up of arcs DE plus EC. EC again is half of our circle, and so I would be doing 4/5 pi plus 3 pi to get 19/5 pi. Okay, let's move on and talk about area now. Area of the circle has one formula, and you probably already know it. It's A equals pi r squared. So if I look at this first example here, I have area pi times my radius, which is 2 squared. Go ahead and take care of the squaring first. So 2 squared is 4, and my area would be 4 pi. This is my exact answer. If I want an approximate answer, this is when I grab my calculator, and I can get area to be approximately 12.566 to the nearest thousandth. Stop the video now, and I want you to do the next one. Be careful, make sure that you find your radius before you try to use the formula, because what you're given is the diameter. When you have it, start the video again and check your answer. Check your answer, make sure that you're having 121 pi square meters for your exact answer and 380.133 square meters for your approximate answer. All right, so let's talk about sectors. In the same way that we talked about arc length in relation to our circumference, we can talk about the area of a sector in relation to the total area. A sector is a portion of the whole area of the circle. What you want to think about here is a slice of pie. This isn't just breaking off the crust like arc length. This would be taking your circle, choosing your angle, and slicing out the whole piece. To find your sector area, this is a lot like you finding your arc length, except you use total area here instead of total circumference. So just make sure that you remember that it's really just a piece of the area, so you'll find the area and then figure out which piece you want. So let's look at a couple examples here. Find the area of the sector as described by the given central angle. So this first one says angle GFH. So if I look for that angle, that is this angle right here. So if I want the area of that sector, I need to start with the area of the whole circle. Since they give me a diameter, I need to realize that my radius is going to be 5 meters. So my area would be pi times 5 squared, or 25 pi square meters. So when I want my sector area, I would be looking for 40/360ths of 25 pi, the portion of the whole circle that I'm looking for. When you multiply this out, what this is going to give you is 25/9 pi, and this would be square meters. Let's jump down and talk about JFG next. JFG, if you look at where this angle is, it is a straight angle because that forms my diameter. So I know that the angle measure here would be 180 degrees because it's a straight angle. So I need 180/360ths of 25 pi. You can also look at it as half of your circle and do half of 25 pi. Either way, you're going to get the same answer, and that's 12.5 pi, or 25/2 if you're going to use the fraction. And again, that would be measured in square meters. HFJ is a little bit different because they didn't tell us the angle measure. But if we know that JFG forms 180 degrees and GFH is 40, then we can see that this one has to be 180 minus 40, or 140 degrees. Stop the video and go calculate the measure of sector defined by angle HFJ, and then turn it back on and check your work. Hopefully you got that one right. We should have 175/18 pi square meters. All right, reflex angle HFJ. Hey, remember that when we talk about reflex angles, we're not talking about the straight one, the shortest distance, we're talking about the longest. So if I look at HFJ, that's this 140 degree angle, but the reflex angle is going to start here and go all the way around to here. So you can look at this two ways. You can either do 360 minus the 140, or if you prefer, you can look at this as 40 plus 180. Either way, you should get this to be a 220 degree angle. So now you should be able to calculate this one. It should be 220 over 360 of our 25 pi. When you reduce this, you should get this to be 275/18 pi square meters. Okay, this last example, no tricks to it. I want you to stop the video and calculate this one on your own. You should have both of these completed when your teacher checks your notes in class, and then you can move on and get your Tier 1 and knowledge check completed.